Welcome and study with Tanzania Institute of Education.
What is an exponent? If you wanted to add a number by itself over and over and over again, multiplication would be a shortcut way to write the addition problem. An exponent works in a similar manner and shows how many times to multiply the base number by itself. It is written to the right and above of the base. The whole term is called a power. Here we can say this is 2 raised to the third power, 2 to the power of 3, or simply 2 cubed. Numbers can be written in different ways. 2 to the power of 3 is equal to 2 times 2 times 2, which is equal to 8. The number written with the exponent is said to be in exponential form. With the product of its factors, it is in factored form, and when we simply write 8, it is in standard form. A number raised to the power of 1 would simply be itself, so the exponent 1 is usually invisible. For example, 2 to the power of 1 would be 2, 10 to the power of 1 is 10, and x to the power of 1 is x. There are a couple of common mistakes to watch out for when working with powers. 2 to the power of 5 is not equal to 2 times 5 and is not equal to 10. It is equal to 2 multiplied by itself 5 times, which is 32. Another common mistake is the position of brackets. For example, -2 to the power of 4 is not the same as -2 in brackets to the power of 4. -2 to the power of 4 would mean we need to raise 2 to the power of 4 before we multiply it by -1, because an exponent takes priority over multiplication in the order of operations. So we would start by multiplying out 2 4 times, and then this answer is multiplied by -1 to give -16. If the -2 is in brackets, this means that -2 is multiplied by itself 4 times. Nothing takes priority over brackets in the order of operations, so the answer becomes +16. The following are the laws of exponents. The product of powers law states that when multiplying together 2 exponents with the same base, we keep the base and add the powers. This is written as x to the power of m multiplied by x to the power of n equals x to the power of m plus n. Let's show that 3 to the power of 2 times 3 to the power of 3 is equal to 3 to the power of 2 plus 3. Okay, 3 to the power of 2 multiplied by 3 to the power of 3 is 3 times 3 multiplied by 3 times 3 times 3, which is 9 times 27, which is 243. If we add 2 and 3, we get 5. So on this side, we have 3 to the power of 5, which is 3 times 3 times 3 times 3 times 3. If you multiply this out, you will also get 243. And we've shown the law works. In the power of powers law, when a power is raised to another power, the exponents are multiplied. For example, 6 to the power of 2 raised to the power of 3 on the left-hand side would be equal to 6 to the power of 6 on the right-hand side. The exponent 3 outside the brackets means 6 to the power of 2 must be repeated 3 times. 6 to the power of 2 times 6 to the power of 2 times 6 to the power of 2. Written out in full, this would be 6 times 6 times 6 times 6 times 6 times 6, which is equal to 6 to the power of 6. And we've shown that this law works. The quotient of powers law states that to divide 2 exponents with the same base, you keep the base and subtract the powers. This means that when 2 expressions with the same base are divided, we subtract the exponents. So, let's show that 2 to the power of 6 divided by 2 to the power of 4 is equal to 2 to the power of 6 minus 4. In other words, that it is equal to 2 to the power of 2. In full, that would be 2 times 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2 equals 2 times 2. This gives us 64 divided by 16, which equals 4. And on the right-hand side, we have 2 times 2, which also equals 4, and 4 equals 4, and we've shown that this law works. The distributive property law states that if an exponent acts on a single term in parentheses or brackets, we can distribute the exponent over the term. This applies to both multiplication and division. For this law, we'll show that 3 times 10 raised to the power of 4 is equal to 3 to the power of 4 times 10 to the power of 4. Here, 3 times 10 all to the power of 4 is equal to 30 to the power of 4, which is 810,000. And here, 3 to the power of 4 is 81, and 10 to the power of 4 is 10,000. 81 times 10,000 is equal to 810,000. The left-hand side is the same as the right-hand side. The zero exponent law states that any number raised to the power of 0 equals 1. We'll demonstrate this law is true and show that 8 to the power of 0 is equal to 1. There are many other possibilities, but let's say that a calculation that would give 8 to the power of 0 could be 8 to the power of 3 minus 3. From the quotient of powers law, for example, when dividing two exponents with the same base, you keep the base and subtract the powers, this would be the same as 8 to the power of 3 divided by 8 to the power of 3, and dividing 8 to the power of 3 by itself gives 1. So any number raised to the power of 0 equals 1 is true. If any number to the power of 0 is equal to 1, what is 0 to the power of 0? Would it be equal to 1? Or is the answer 0 because we know that no matter how many times you multiply 0 by itself, the answer is always 0? In fact, 0 to the power of 0 has an indeterminate answer. The negative exponent law states that a number raised to a negative exponent is equal to the inverse of the number. So, for example, x raised to the power of negative 1 is equal to 1 divided by x. To understand how negative exponents work, have a look at the pattern in this sequence of exponents formed by powers of 5. 5 to the power of 3 equals 125, 5 squared equals 25, 5 to the power of 1 is just 5, 5 to the power of 0 is 1, 5 to the power of negative 1 equals 1/5, and 5 to the power of negative 2 equals 1/25. You'll notice that at each stage we divide the answer by 5 to get the next number in the sequence. What happens when we raise a number to a power that is a fraction? Remember the first law of exponents, the product of powers. The base is the same, and we are multiplying the bases so we can add the exponents to get 100 to the power of 1/2 plus 1/2. This means that 100 to the power of 1/2 times 100 to the power of 1/2 is equal to 100. What do we call a number that, when multiplied by itself, results in a specified quantity? It is the square root of the number. So 100 to the power of 1/2 is the square root of 100. Let's take the power 5 raised to a quarter. If we repeat 5 to the power of a quarter 4 times in a multiplication, we get 5 to the power of 1/4 plus 1/4 plus 1/4 plus 1/4, and this is equal to 5 to the power of 1, or just 5. This means that 5 raised to the power of 1/4 is equal to the fourth root of 5. We can write a general rule for fractional exponents. A number raised to the power of 1/n is equal to the nth root of the number.